Hello everyone. Today we are going to learn about the conversion of numbers from base 10 to base 2, 4, 6, 8. So the first is to conversion of number from base 10 to base 2. So I am taking example here 6. So we are converting to base 2. So we have to divide the number uh, with this number which we want to convert into. So here we have to divide this number with 2. So I am taking the number 6. So let's divide this 6 with 2. 2 3 is 6 and the remainder is 0, and 2 1s 2 and the remainder is 1. So as here this number is less than this number, so we have to stop here and we have to write in this way. So write that number 110. So let's check whether it is right or wrong. So we are converting to base 2. So we have to write from the right side in the units place 2 power 0, 2 power 1 and 2 power 2. So calculate 4 plus 2 equal to 6. So it's right. And next example is, let's take the number 10. So here 2 5s 10 and the remainder is 0. 2 2s 4 and the remainder is 1. 2 1s 2 and the remainder is 0. So the number is 1010. So let's check again in the same way 2 power 0, 2 power 1, 2 power 2 and 2 power 3. And we calculate, we get 8 plus 2 equal to 10. So this is how to convert from base 10 to base 2. Now let's go to base 4. So taking the example 16. So we are converting this number to base 4. So divide with that number 4. 4 4s 16 and the remainder is 0. 4 1s 4 and the remainder is 0. So the number is 100. Let's check 4 power 0, 4 power 1 and 4 power 2. So 4 square 16. So it is right. And next, second example is 46. 4 11s 44. Remainder is 2. 4 2s 8 and the remainder is 3. As it is less than this number, so we have to stop and write the number 232. So from again right side 4 power 0, 4 power 1 and 4 power 2. Evaluate, that is 32 plus 12 and plus 2, which is equal to 46. So it is right. Next conversion is to base 8. It is also called octa. So here we are taking example 32. So 8 4s 32 and the remainder is 0. So the next conversion is to base 8. So let's take the number 32. 8 4s 32 and the remainder is 0. So 4 0. 8 power 0 and 8 power 1. 8 4s 32, which is right. Second example is 50. So 8 6 are 48 and remainder is 2. 6 2. So from right 8 power 0 and 8 power 1. 48 plus 2, which is equal to 50, and this is also right. And the next conversion is to base 16. So which is also called hexa. So now here see the first example. I am taking the number 16 and divide this number with 16. 16 1 16 and the remainder is 0. So here 1 0, 16 power 0 and 16 power 1, which is equal to 16, correct, but this is not right way to represent this. So the right way to represent the hexadecimal number is 0x. So 0x10 is the right way. So in the same way, second example is I am taking 255. So 16 15s 255. Remainder is 15, but here we should not represent as 15. Here see, in this we have digits like 0 to 9, but from 10 we shouldn't represent as it is 10. There is some way to represent that. So 10 is represented as capital A, 11B, 12C, 13D and 14E and 15F. So here there is here and the remainder is 15. So we have to represent 0xff. So this is the conversion of, so this is how to convert the numbers from base 10 to base 2, 4, 6, 8 or 16. 2, 4, 8, 16, sorry. So now the next topic is IP, Internet Protocol. So IPv4 means 4 numbers. Each number can be range of 0 to 255 and separated by dots. So it consists of 4 bytes. This is the way to represent IPv4. Next is IPv6. Here 8 numbers and each can be separated by colon. It is notation is hexadecimal notation and has 16 bytes. So this is the notation of the IPv6. Next is representation of audio file. So audio files are represented digitally by sampling analog sound waves at regular intervals and converting the samples to binary data. So see here how the audio file is represented in each way. So when there is low frequency and when there is high frequency, low amplitude and high amplitude. So these are the waves when in different conditions, these are the waves. So the next topic is representation of image with pixels. So image is represented as 2D matrix of pixels where each pixel is represented as 3 bytes containing of RGB colors. Each color value range is 0 to 255 or 0 to 0xff, where 0 is no light and 255 is maximum light. For example, a pixel with red equal to 255, green equal to 100 and blue equal to 0 is a shade of orange. And for a 200 to 300 image, there will be 60,000 pixels, which means 1,80,000 bytes, and which means that is equal to 180 KB. So the next you will learn this about RGB colors and how they represent, how can we edit. Okay, our next topic is RGB. So this is RGB means red, green, blue, and this is used to edit colors. So you're seeing here that is hexadecimal numbers already we have learned. So we will use that concept here. So here see 255 you are seeing now. So all these colors are in the range of 0 to 255. So when all these three colors are in 255, then the resultant color is white. So here if we give all these three colors 0, so we will see what will be the resultant color. So see here the resultant color is black. So according to these numbers, the resultant color will come. So by using this method, we can create the number of colors. See, number of shades also. So this is the uses of this RGB. Okay.